Hello, welcome to SoftwareDude. So this video is going to be very important for your interviews. If you are going to give a system design round, if you are going to give a interview for SD2 or any levels above SD3, staff engineer, principal engineer, this is one of the rounds that always happen. And there is a pattern that you should follow, which I have built into a 6-step framework, which basically helps to navigate any system design problem, right? System design to start with, when they are actually trying to discuss system design problems and trying to gauge your technical capability, what are they trying to exactly see? They are trying to see whether, given a problem statement, given a requirement, right, you can derive that requirement from ambiguity to clarity to design a system with the components that will be involved, and then going deep into the systems and the services that will be involved, defining the kind of low level details that are needed for the design to actually work, like for example APIs, database, whatever those are, and then actually deriving that, right? So in a 45, 50, 55 minute time window, when the system design round happens, when the question is asked, how should you actually prepare for that, and what should be your answer in that 1 hour interview round, right, for system design? So let's start. Step one is to clarify the requirements, right? You shouldn't spend more than 5 minutes on this. For example, when you look at requirements, there are multiple ways of defining a requirement, right? The first is the functional requirement. What are the features that the system must support, right? So what are exactly the user stories, if you can get, or at least ask about what are the capabilities that the system will provide, those kind of things, right, which are called functional requirements. Next is the non-functional requirements. This is one of the critical pieces because this defines the system behavior, right? How many number of users, the RPAs, the data size, what is the scale, right? Those are the non-functional requirements. And then the constraints of the system, right? What are the latency targets? Should the system be 99.99% available, right? What are the budget constraints or the cost constraints, right? These define the requirements that you should be clarifying before diving into giving out any solution, right? So first clarify the requirements. For example, how many daily active users? Say if you are designing, if you are given a system which will be used by consumers, so how many daily active users? Is it a read heavy system or a write heavy system, right? Does the data need to be globally distributed, right? Which region customers will it be supported, right? So those kind of requirements, clarification, help in time in terms of defining what are the goals that you are trying to design the system for, and what is in scope of the system design, and what is out of scope of this system design question that is being asked, right? Next, step two is capacity estimation, right? Again, you shouldn't spend more than 5 to 7 minutes on this. Capacity estimation, you should be using a back of the envelope math to understand scale, basically, right? Simple formulas, right? For example, storage estimation, right? What is storage? If you are thinking about every data will be stored as a record, and then what is the size of per record, right? So that gives you a storage estimation, number of records into size of per record, right? That is storage estimation. For example, bandwidth estimation. Bandwidth estimation is given by the QPS into the number of average response size, right? So storage estimation primarily tells you if your data will fit in one machine or it will require distributed storage, for example, right? So if we take an example here, say there are 1 billion user profiles, right? And for each record, it is 2 KB size. So 1 billion into 2 KB, it becomes roughly around 2 TB, which can technically fit into a database, right? But if your system design is asking for a requirement where you have to store 1 billion photos, right? And for each photo size is 5 MB, right? So that comes out to be around 5 petabyte of storage, right? That will not fit into one database. For that, you will probably need an object storage, like for example, S3, right? Bandwidth also, when you do a bandwidth estimation, basically, why do you do it? You do it because it reveals if you need a CDN, right? a delivery network? Do you need that, or a single data center can handle the traffic load, right? So these quick estimation, for example, if we take a bandwidth estimation example, right? Say you have 10,000 QPS or 50 KB response size, right? That becomes approximately 500 MB per second ish, which is approximately 4 GB per second, right? 4 Gbps is a single server with probably 10 Gbps can handle this load, right? But if you have 1 million QPS or 500 kbps, right, that goes in terms of almost 1 terabyte or like probably 500 GB per second, which requires a CDN distribution, right? So these things will basically help you, whether you need caching, whether you need CDN, whether you need sharding, right? Like those kind of techniques will basically be applicable if you are doing the capacity estimation before diving into the system design, right? Once these two are defined, any system that you will be designing will obviously have APIs, right? Most of the systems that you will be designing, depending on the kind of problem, but most of the system design rounds will have an API round, like API will be part of that solution. And so defining the API, so that is where probably HTTP API or REST API, understanding of that is very important. And you should be able to quickly define the APIs and not spend more than 10 minutes on this. Generally, in a system design round, the kind of APIs, like for example, depending on your use case, their CRUDs are generally anyways always needed, right? When you are actually creating or updating or retrieving or like deleting a record, right? Like so CRUD operations. So if you are inserting some data, you will probably use a post API, right? If you are fetching or retrieving some kind of data, you will use a get API, right? So defining your APIs and the contracts for the APIs is step 3. That gives a clear cut specification based on how your system will basically be designed, right? So if you have to support a post, for creating a post, and this is the structure that you will have to follow, then that will define what kind of system and what will your structure look like. If you have to define a get, and then you have to query by say user ID, and then also have to have a limit, then that also gives you a requirement for pagination. And like for example, do you support queries, do you need indexing, right? So defining the APIs and not more than 10-15 minutes. Generally it depends, but I don't think it will, for any kind of system design, 4 to 5, like less than 10 APIs is at max that I have seen ever. So it's primarily around a system that you are designing, and that system within the scope of the interview shouldn't take more than like 10 to 15 minutes to define the API contracts. Now when you have the requirements clarified, you have the estimation, like capacity of the system, you have also defined the API contracts. Now you should dive into the high level design. Most systems that you will design will follow one pattern, and it's a very safe pattern to follow, and then you can expand on top of that, right? Which is, you will have the clients who will be calling. Now who are the clients? Clients can be the web browser, it can be another system who will be calling your API, or it can be a mobile app, right? Like so any client, when the request lands on your system, you will probably always need a load balancer to balance the traffic, right? The load balancer is going to transfer the request to your app server, which can also be the compute where your actual function business logic will reside, right? And then this business logic always works on top of the data, and that is where the storage comes into place. In general, if it is structured data and you want quick lookups kind of use case, then database. And then if those are not very write heavy, very low frequency writes and mostly read heavy systems, then you can also put a cache in between, right? And then depending on what your kind of system is, if you are going to store videos or if you are going to store photos, for example, that might not reside in a database. You might want to have a storage or a object storage, for example S3. So that is how it will generally define. But goal of the interview is that you draw boxes draw arrows, define the boxes, write what each of those arrows are doing, right? From where to where and what are the request or what is the passing. So let's take an example. So let's say if you are designing a tiny URL, right? So very similar architecture. If you see, you have a browser, which is the client. You have a load balancer. The load balancer is forwarding the request to the app servers. The app servers are writing to a database and at times reading from a cache. If there is a cache miss, then the cache then itself also reads from the database, right? So this layer more often than not generally works, right? So this is something that you should keep in mind. And then depending on the system, you can add boxes. So when you are actually giving the interview, whether you are writing on a whiteboard or defining on a tool or on a web, always try to focus on drawing the boxes, defining the boxes, drawing the arrows clearly, writing what each of those arrows mean, right? And that will basically give you a high level confidence in terms of the system to define that, right? And because you have already defined the APIs before, so you already know what are the APIs that will be supported, and based on that how your system is evolving, right? So this is one of the most critical like parts of a system design round, where they want to get this definition, this design, high level design, very clear. And you also define the APIs before that, right? Now once you have that, the next step is, now that you have defined this, you should be able to identify bottlenecks. Now how will you identify the bottlenecks? Those will come from the capacity estimation that you did, the functional, non-functional requirements, as well as the constraints, right? So if you have the constraints and the capacity estimation and the functional, non-functional requirements, that will basically define whether the system, the high level design and the APIs that you have designed will work or not work, and what can become a bottleneck. So looking at your diagram that you have designed in the high level design in step 4, you should first start with the biggest bottleneck first, right? So try to figure out what is the biggest bottleneck. So for example, are the database writes going to get saturated, right? Will the network bandwidth, like will there be bandwidth between the regions, right? Will there be CPU on the app servers, like will they be able to handle during peak, right? How is the peak traffic going to be? How is the burst traffic going to be? Like these kind of topics and questions will define what are the bottlenecks. And then based on the bottlenecks, you talk about the trade-offs, right? And so this part you should keep at least 10 minutes to discuss the trade-offs, because this is important, because no system really is a black and a white, right? It's always gray, and it's always depends on the trade-offs, like I've always said in all my videos, right? So depending on how your system is evolving, how you are identifying the bottlenecks, and based on that, the choice of the high level design that you have made, each of the components, that is where you discuss each of the trade-offs. Like for example, how will you handle cache invalidation, right? If you have put a cache, how will you handle that? And there are multiple ways to handle cache invalidation, right? You have had you designed a database, but should it be a SQL or should it be a NoSQL, right? And that is where you evolve different types of database choices and what is the right fit for this design, right? Will there be synchronous writes or asynchronous message queue, right? In the example that we took, we didn't have a queue because we were thinking it will probably be a synchronous API, right? But if you have, and your capacity estimation and your system design and the requirements are deriving that there might be an asynchronous requirement, right? Probably a job that is needed, a scheduler that is needed, and probably a step function which will do an orchestration of some kind, right? Those will all be asynchronous, but for that your system will, now you will have to go back, add more boxes, move some of the arrows to add an asynchronous workflow, probably an engine somewhere, right? A platform somewhere, right? So that is how the system is evolving, right? So by the end of this, the 6 steps, starting from requirement clarification to the capacity estimation, then you are defining the APIs, the high level design, and then from there you are identifying the bottlenecks, and then diving deep on each of the trade-offs for each of the bottlenecks and each of the constraints, and then evolving the system, iterating over it, right? So that is technically, if you count the minutes, that will come to around 50-55 minutes. That is a good enough system design round if you are able to draw this, right? So let's recap. So system design is basically a discipline of building systems that work reliably at scale, right? It should be able to handle millions of users, petabytes of data. Like, scale is important, and that is what interviewers want to see when you are designing a system, whether you are considering that. Not that you will have to design for that always, but you are talking about those things. You are actually designing, you are defining the trade-offs, and you are talking about the constraints, the requirements, which is where we come to the non-functional requirements, which is where what will be the latency, what is the throughput. If we are doing a streaming platform for videos, right? I mean, so that cannot have a lot of latency. It has to be very fast, right? Whether the throughput will be good or not for those kind of systems. Do you need a high availability system, right? So those kind of things derive and drive the architectural decisions more than the functional requirements, which are the basic product use cases, right? So the non-functional requirements, defining those are important, which comes to the capacity estimation. Is basically using concrete numbers, right? What we discussed, storage, bandwidth, QPS, like those kind of things basically help identify bottlenecks before you are actually designing the system, before you are starting to build the system, right? Then obviously follow standard architectural patterns, right? And which will evolve basically as the scale increases, right? Starting from single server to load balancing, you probably might need to add caching, sharding, indexing, might be different concepts, but start from a basic 5 block system, starting from clients to load balancer to app server or compute to a cache and a database. That generally works, and then from there you evolve based on asynchronous need, caching needs, sharding needs, right? So that generally helps. And then the final step is to talk about the trade-offs, right? Trade-offs are unavoidable, right? So consistency versus latency, right? Cost versus performance, simplicity versus like scalability, right? So like I always mention, like there is no perfect architecture, only appropriate choices for the requirements that are given to you for this question, right? So hopefully you have a great system design interview round and follow this 6-step framework. I have myself used this and cracked multiple FANG interviews. So this is definitely works. And then how do you define, how do you evolve different systems based on the need? That will be that will depend on the question that will be at hand. All right, best of luck. Thank you for watching.